Hey everyone, it is Mr. Vargas here, checking back in with Math 3, looking to help students out with homework 4.5, solving polynomial equations. Now when we're solving polynomial equations, what we're basically doing is finding a value of a variable that makes the polynomial equal to 0. In other words, you're checking out where your polynomial crosses the x-axis. Remember, this is also called solutions, roots, zeros. So solutions, roots, zeros, and all of this has to just basically do with where your polynomial crosses the x-axis. So, here's a random polynomial. And here it would cross the x-axis. There, there, and there. So this picture is a graphical representation of solutions. Now we're going to use some different methods to get these answers algebraically. Alright. Some things to remember when solving equations or solving polynomial equations. First thing is get your equation equal to 0. So basically we're going to move everything to one side of the equation so that it is set equal to 0. The second thing is going to be factor and solve. And then sometimes we're also going to use the quadratic formula if our polynomial is in quadratic form. And I'll show you an example of that. Really quickly, we learned about this in class, but some important tools that can help make factoring really quick involve the difference of squares. So if you have a term squared minus another term squared, you can write it really quickly as this factoring. Sum of cubes, a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. All this does is make something that's a little bit more complicated into something that looks, or it's similar, or not similar, it's simpler, easier to solve. We don't really like solving cubed stuff. We can work with squared stuff a lot better. And then we've got difference of cubes, very similar to the sum of cubes in terms of its factorization. And then also, just a quick heads up, some perfect square trinomials. So if you ever have anything in this type of form, we can rewrite it as this. Or if you ever have anything in this type of form, we can rewrite it as this. These are called the perfect square trinomials. Alright, let's get into some homework examples. We'll start out with number 1. So we've got x to the 4th power minus 49 equals 0. Okay, so thankfully in this equation it's already set equal to 0, so we can just start to attempt to factor this type of thing. Now, x to the 4th might not look like an x squared, but we can rewrite this so that it is something squared. And with a lot of these problems, you just kind of have to be clever and rewrite things so that they look like the difference of squares, or the sum of squares, or the difference of cubes, and so on. So here I'm going to recognize that x to the 4th can actually be rewritten as x squared to the power of 2. Remember, 2 times 2 is a power to a power, so we multiply our exponents, that gets me x to the 4th. And 49 can be rewritten as 7 squared. Okay, now we have the form a squared minus b squared. So x squared becomes my a, and that 7 becomes my b, and we can use that formula for the difference of squares and basically just rewrite this as x squared plus 7 times x squared minus minus 7 equals 0. Alright, now we can set each of these factors equal to 0 by itself, and then solve from there. So here I would take x squared plus 7 equal to 0. Solve that equation, and then over here I would do x squared minus 7 equals to 0, and solve that equation. Let's do the one on the right first. So I add 7 to both sides, and I get x squared equals 7. Then I take the square root of both sides, so you'd get x equals, and when we take the square root of something, we have to consider the positive and the minus version of the solution set, or negative version. Good, so this part of your answer. Now we got to figure out this left-hand side. So if I subtract 7 from both sides, I get x squared equals negative 7. Now take the square root of both sides, and you get x equals plus or minus the square root of negative 7. We can rewrite this negative 7 square root simply as pull out an I, imaginary numbers. So it would be plus or minus I square root 7. And those are your solutions for that polynomial. Alright, let's check out another example. Let's try number 2. Okay, number 2, x to the 4th minus 6x squared equals negative 8. This one is not all set equal to 0, so I'm going to move that negative 8 over to the left hand side of the equation. There we go, that's a little bit better. Now for this problem, we realize that this can be broken down into, we can factor it into a simpler form. And for this one, it's going to be x squared times x squared. And then how can I make an 8 so that I end up with negative 6 on the middle? And that is just going to be negative 4 minus 2. Double check my work. Negative 4 times negative 2 is positive 8. Negative 4 plus negative 2 is negative 6. Okay. From here we recognize that this this factor on the left, this factor on the left right here is the difference of squares. So we can break that thing down into x plus 2, x minus 2, then bring down your other factor. Alright, now we've got 3 terms, so set each term equal to 0 and solve from there. So the first one is just x plus 2 equals 0. The second one is x minus 2 equals 0. Those are easy. And then the third one is x squared minus 2 equals 0. Okay, first one, you just get x equals negative 2. That's a solution. Second one, you get x equal to 2. That's a solution. And then the third one, add 2 to both sides, and you get x squared equals 2. Take the square root of both sides, and you get x equals plus or minus square root of 2. So basically you have 4 answers here. X equals negative 2, x equals 2, x equals positive square root 2, and x equals negative square root 2. So when you go to graph this polynomial up here, x to the 4th minus 6x squared plus 8 equals 0, these answers down here are where your polynomial will cross the x-axis. Okay, let's check out number 4, and this will be the last problem that I do on here. For this one, first we have to recognize that we can actually factor out a common factor from both of these terms first before we start. And that common factor is going to be 3t squared. Okay, 3t squared times what will make 3t to the 6th? That would just be a t to the 4th. So if I multiply those two out, 3t squared times t to the 4th, that gets me back to this original term, minus 3 times 16. And that would be it for that one, right? Because 3t squared times negative 16 would get you back to negative 48t squared. And that's all equal to 0. Okay, this thing right here, t to the 4th minus 16, that is definitely the difference of squares, where it's in the form t squared minus 4 squared. Okay, and I'll bring down everything else. Whoops. So, using our formula for the difference of squares, we can rewrite this whole thing as 3t squared times t squared plus 4 times t squared minus 4. Awesome. Now I can break this down even further and recognize that, hey, this term right here is also the difference of squares. So let's go ahead and rewrite this. T squared minus 4 is just the same thing as t plus 2 times t minus 2. Fantastic. So now I'll leave it up to you guys to set each of these terms equal to 0 and solve for the different values of t. I'll show you the easy ones. This is going to be 0. This would be negative 2. And this would be a 2. So set this bad boy equal to 0 and see if you can solve for the other missing values of t. Alright, that's it for this video. See you in class.